we start by, I already logged into my AWS account. The first thing I'll do is, I'll try to install AWS CLI. Okay, so AWS CLI links and all I already given here. So these are already covered in multiple videos. So if you want to know, otherwise let's try to, create everything here. Install or update the AWS CLI. Okay, so for Windows, basically you can download this and run this installer. For Linux and all, you already have the instructions given. For Mac OS, it is, I think, simple brew install AWS, or I think so, or else you can just curl that package. Okay. So for Windows, I can basically download that MSI file. I'll simply click on this, and then it will just download that AWS CLI. So all I can do is just double click on this, and then you should proceed with installation, right? So I'm not going to cover this, or let's wait. So meanwhile, our next requirement is to install kubectl and EKS-CTL. So let me open that link as well. Again, you have the options to install kubectl on all three operating system. I also have a dedicated video, so you can search it in YouTube, or else I'll leave a link in the description below. So install kubectl on Windows. So what you can do is, using curl, you can basically download the exe file. Okay. So, or else the other way is to, you can go to the release page, I think. uh, I'll just click on this kubectl here, and then automatically it will download. So let me just download that as well. And what's the status of this? So let's click on the next. Okay, so we are installing AWS CLI, and the thing is, we already have kubectl installed, sorry, uh, downloaded here. But the problem with this is, it is not recognized from other locations. So this is there in my Windows. So for example, if I open CMD within downloads folder, I can simply say kubectl space exe something. So it is going to respond. But if I open it terminal in probably in a different location. I have included old version of kubectl in the path. That's the reason it may respond. But in your case, if you try to run kubectl in a different location, it may not work. I'll also explain how to fix this. So what I'll do is, I'll try to just you know take this kubectl. So I'll put this inside a path. Okay, and I can update, I can set this path as well. So what I did is, I created a folder called tools within C drive, and here I'm collecting all my utilities. Okay, so for example, I just pasted my kubectl here. Okay, and since this is a separate folder, and this separate folder has to be included in the path, otherwise your system may not find all the utilities that I have here. Okay, so for this, you can search for environment variables. Okay, by simply searching for environment variables, and then clicking on environment variables here. Okay, under the system variables, just double click on the path. If you see, the C drive tools is already added to my path here. Otherwise, you can click on new, add that path, and click on OK, and click on OK here, so that environment variable path is updated with this particular location. Now I can, basically open terminal, go to any location, and then run kubectl. It should work. For example, I open CMD and run, kube uh, CTL. Okay, then it should run. Okay. And also we have installed AWS as well. So if I just do AWS -H, it should also respond. Okay, so AWS CLI is also installed, successfully. Now it's time to install EKS CTL. Okay, EKS CTL. This is the link. Okay, so I included links for EKS and all. It's not required. Okay, you can just go to this vworks repository and basically go to the releases, click on the releases. So version 0185, this is the latest CKCTL release. I would like to download for my Windows AMD 64. Okay, so if you're on Linux, okay, and AMD architecture, this is the correct file. For ARM, this one. For Mac, it is Darwin, either AMD 64, or if you're using latest M1 or M2, it should be ARM. So in my case, it is Windows AMD 64. I'll simply, I'll download it directly into that C drive tools folder. Okay, but it won't work like that. So basically, you need to extract it. So I'll be extracting that particular folder here. Let's delete the zip file. So inside the folder, you have EKSCTL. Just cut it from there and place it directly in the tools folder. Okay, if you have any old version, it will automatically replace. And then since this folder is empty, you can delete this as well. If you see, I have kubectl EKSCTL available here itself. Okay. And now what we will do is, we'll try to create an IAM user and configure our local AWS CLI. So for this, I'll log into my AWS console, click on this IAM. Okay, click on users. Okay, currently Atlantis is one user that I already have, but I'm going to create one. So I'm going to name this user as developer. I don't want him to have AWS console access, so let's click on next. Attach policies directly. I'm going to give him administrator privileges by giving administrator access here. Click on next and click on create user. But till now we did not set up the credentials for this user. So just click on that developer user, go to security credentials, and then create access key. Okay. So create access key for command line interface. Click on confirmation, click on next. Tag is not required. So you can download these credentials in the form of a CSV file. Okay, so I'm going to just download it. Okay. So you also have an option to copy access key and secret access key here. So let me um, just copy it somewhere. Okay. Anyways, I'm going to delete them later. So this one is my access key and the other one is the secret access key. Okay. Now after this, if you go to your documentation, after you create the IAM user, you need to run AWS configure. So this will configure your AWS local CLI. So you can do it in any terminal. So I'm just doing it in my Windows CMD. Okay. AWS hyphen configure. So it will ask you for AWS access key. Okay. You can copy from your AWS, or you can just copy from the already copied one. Okay. And then this is my secret access key for AWS. I pasted. Default reason is AP South 1, or else you can just, if it is already AP South 1, you don't have to give anything. You can simply press enter. Otherwise, you can provide a reason of your choice. Default is JSON, so I'm not giving anything else. I'm simply saying, I simply pressed enter. So now my AWS CLI is configured, right? So once the AWS CLI is configured, I can now run some commands. So for example, you can run it in any terminal. Okay, I switch it to VS Code terminal. So here I'm running AWS IAM list users. So if you go to your AWS console, in my case, basically there are two users, Atlantis and developer. You can see the same thing, Atlantis and developer. So which proves that our AWS CLI is working as expected. Now let's create the cluster. Okay, so cluster creation will take a lot of time, probably 20 to 30 minutes. Okay. Let me explain that command as well. So I already cloned that repository to my local machine. Okay. So this is the command that we are going to run. So we are running EKS create cluster. The name of the cluster is demo. In the region AP South 1, node group name is also demo. Nodes, the initial nodes are 2, and the node volume size is of 2. Okay, 8 GB. So let me copy this and just run this particular command. Okay, so this will take almost 20 to 30 minutes. So I'll come back. So once the cluster is created. As you can see, Reke's cluster is up and running. So once we create the cluster, so we can get the cluster in a specific region by running ekctl get cluster followed by the region. So we have a cluster by the name demo in the AP South 1 region. And once this is done, so in order to talk to your cluster, you need kubeconfig file. So using AWS CLI, you can basically get the kubeconfig file, right? So AWS EKS, so you need to have AWS CLI installed. Get the config, basically for the name demo. That's the name of the cluster from the region AP South 1. So once this is done, you will have the kubeconfig file updated with the information about this cluster. Basically, it adds a another context and sets that context as the current context. So now let's get the number of nodes in this cluster using kubectl get nodes. You can see there are 2 nodes. Okay, so everything is already described in this documentation. So now once we have the cluster, we need to have OIDC provided associated with this particular cluster. So I'm going to run this particular command to associate an OIDC provider. And this is clearly mentioned in the EKS documentation as well. So after this, if you want to know the OIDC issuer URL, you can run this command. So which will just print the OIDC issuer URL. And after this, we will try to deploy AWS load balancer controller because we'll be exposing our application through an ingress. And for every ingress that is created, we need to have a load balancer created for us. So for this, we need to deploy AWS load balancer controller. So which is just like an EKS add-on, and the entire documentation is available here. So for this AWS load balancer controller to work, you need to create an IAM policy. And that policies document is already available under Atlantis deployment folder. So if you go in this folder, you will basically find a policy document. So let me open it here. I think it's there in my local, no, this one, this IAM policy itself. So this is the the actual policy. Okay, again, this is taken from EKS documentation itself, so you don't have to know what exactly is this policy doing here. Okay, but the load balancer controller requires this permissions to create ALB on your behalf. So for this, we need to create an policy, and the name of the policy is this, and this is the policy document, so which is available under this folder. So once this is created, basically you can also log into your AWS console and go to the IAM policy section and see this policy, that is customer managed policy. And then you need to create a service account, that is IAM service account. So this service account is needed in order to give the AWS load balancer controller, I mean, whatever application that we are going to deploy. So it needs certain IAM credentials, and those credentials are provided via an IAM service account. So we need to create, basically a IAM service account for this cluster demo within the namespace kube system, because our add-on AWS load balancer controller is going to get deployed in this namespace. And the name of the IAM service account is this. This is the role name. Okay. That is the role name that is going to be created, and attach policy. So basically, whatever is the policy that you have created, you know, you need to mention the ARN of that policy. And this is basically your AWS account number. Okay, so you need to replace this with your AWS account number, and then apply this, run this particular command. Okay, so once this is done, so once this execution is completed, you will see that the service account is created. It is going to take a little bit of time. Okay, you can see the service account is created under this particular namespace. So after this, we need to add the Helm repo for EKS charts, and then update your local Helm index. So I think it's already added. So it is just giving, just saying that EKS repo is already added to my local machine. So after that, we will release this Helm chart from the CK Helm repo. The name of the chart is AWS load balancer. Okay, it also requires the cluster in which this load balancer has to be created. The service account create is false because we already created a IAM service account previously. And the service account name here, it should be the name of the service account that we created here. Okay, so this is going to install AWS load balancer controller via Helm chart. So for this, you need to have Helm installed. If you are not sure how to install Helm, I'll leave a link in the description below. So you can follow that video and have Helm installed in your machine. And once this is installed, so you can just get the deployments in the kube system namespace, um, and look for the deployment by the name AWS load balancer controller. So again, there are two pods for this deployment. So you can see both the pods are in the running state. And this is the command for deletion of the cluster. At the end of this demo, you can just use this command to delete the entire cluster. But before that, make sure that you uninstall all the applications. Then you go ahead and delete the cluster. Okay. Now it's time to install Atlantis. So Atlantis can be installed, as we already said, so via Helm chart or a deployment file. So here is a deployment file for the Atlantis. And Atlantis requires AWS credentials, and also we need to pass your a GitHub token, and also a webhook secret. Okay, so all these are clearly mentioned here in this particular documentation in the README file. So first I'm going to create an personal access token and a webhook secret. Okay, so let's create a personal access token. So I'll log into my GitHub, click on the profile picture, and click on settings. So in the settings, you need to go to the developer settings, go to personal access token, select tokens classic. You can delete the one. I mean, this is the one which I created previously, but let me create a new token of type classic. So the name of the token I'm going to say as demo. Expiry, I'll just set it to 7 days. And coming to the scope, right? So if you look at the documentation, I already updated it. What exactly the scope of that token? So it says, you should have a repo scope. You can also go to the Atlantis documentation, click on installing, and then GitHub, Git host access credentials, and then select GitHub here. So you need to create a personal access token with repo scope. So I'm going to do the same with repo scope, and then click on generate token. Okay, so this is a token. Just copy the token and then close the window. Otherwise, you can't see the token. So you have to create a new token. So this is the token. And after that, I need to have a webhook secret, which is greater than 24 characters. So basically, you can generate a random string. So I'll say, so, random string generator online. So 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 random string generator and then generate a single string of, let's say, probably 26 character. Just don't include numbers. I don't know whether numbers will work or not. So let's stick with upper and lowercase letters and just get the string. So this is a string. So this is basically your uh, webhook secret. And after this, what we need to do is, so we need to create a token. Um, you need to create a token, basically secret, with this data. So what I can do is, I can echo my token into a separate file, and a webhook secret also into a separate file. Okay, or else you can use environment variables, but this is how they're using in the documentation. So what I have to do is I have to simply say echo -n, and then so my GitHub personal access token. So after that, they're asking me to redirect it to a name known as token, and similarly echo -n. So I need to use my webhook secret, which is greater than that 24 characters, and then redirect into a file known as webhook secret, right? And then you need to create a secret of type generic, and this is known as Atlantis VCS secret. And the secret is being created from the files. Those files are a token and webhook secret, which we created in the um, previously in the previous steps. Okay, so now it's time for AWS credentials. So here I created the deployment in such a way that I provide these credentials in the form of environment variables, but you have multiple ways of providing credentials if you go to the documentation. For supplying these provided credentials, you can use EC2 roles or instance service accounts for GC. You can also use IRSA role, that is basically IAM role for service accounts. There are multiple ways. Okay. You know, you can also use a role here, assume role. But for simplicity, I'll be providing them through environment variable. So we know that AWS has two separate variables, so which are access key and secret access key. So those serve as credentials for your authentication, right? So I'm going to create a secret by the known as AWS credentials, and I'm going to supply my access key and secret access key. Okay. So let me just copy this command in a separate window. Okay. So I need to replace my access key and the secret access key here. For this, uh, you can use the credentials that you already uh, stored here in your local machine. So when you're configuring the AWS CLI, okay. Anyways, I'm going to just revoke this at the end of this demo. So this is my access key, and the other one is secret access key. So AWS access key equal to, I'm going to replace this XYZ with the actual value, and the secret access key, the AWS secret access key, ABC with the actual value. And I'm going to create this particular secret here. Okay, so now my both the secrets are created. Since my deployment is expecting these two secrets, so we have created. Now it's time to apply the deployment file. So this is the deployment file of Atlantis. You can see we are supplying credentials as secret, and also GitHub user token and the webhook token also has secrets here, these two. And also, so here we have um an ingress file. Okay, so it's an internet facing type. So ALB is created. Okay, and other routes. Okay, so this is how the ingress is written. So I can access Atlantis, and Atlantis also expects its URL. So basically, this is going to your ALB URL. Since that is not available yet, so I think I'm using an old one. Otherwise, you can just set a random one for now. So once we have the actual URL, we are going to update this here, right? Now, what I'm going to do is I'm going to apply this manifest file. the deployment.yaml file. So they should create a pod service and an ingress file. Okay. So you can see, so the pod Atlantis in the creation state, it's running, and you have Atlantis service, and also you have the ALB. So what I'm going to do is I'm just going to take this ALB here and then update my Atlantis URL with this one. Okay, and then I'm going to just apply this manifest file again. So only deployment changes, and you can see that service and ingress remains the same. So deployment will be reconfigured. Okay, so the new environment variable will be taken into effect. You can see the old pod is running and new pod is in container creation state. Okay, so I think we are missing HTTP or HTTPS. So here I need to mention HTTP. So that's the reason it is erroring out. So let me change it and deploy. So now you can see that your Atlantis is in the running state. Now this is the ALB address. I can simply visit this ALB. So it says service temporarily unavailable. Yeah, so now if you refresh, you can see that Atlantis is in the running state. So now once it is ready, so you need to configure webhooks in GitHub. So GitHub can send webhook payload to Atlantis. Okay. So what we need to do is we need to take the Atlantis ALB address, go to your repository where you have the Terraform code, go to the settings and click on webhooks. So I have some previous ones, so I'm deleting it. Add a new webhook. So the payload will be HTTP or ALB address, followed by the endpoint known as events. Okay, and the content type to be application JSON. So here comes your secret. So this is your webhook secret that you have used while creating the um, you know while creating your secret, right? So I think I missed it. So I can just, oh, I missed it. So what I can do is I can just check here in the history. So this is my webhook secret that I just generated of 26 characters. So I just paste it here. And for the events, you need to select proper events. So it is already given in the documentation if you click on configuring webhooks. So here for the GitHub, you need to check these events like pull request reviews, pushes, pull requests. Okay, so issues, pull request events, pull requests, pushes, issue commands. Okay, issue commands. You need to select these, but you can also have extra ones, or else you can also just say send me everything. Okay, and then click on add webhook. So once you refresh this page, this webhook should be successful. Okay, so which means your GitHub is able to talk to Atlantis using the ALB ingress address, right? So now, so we have everything in place. We have the UI and we have the webhooks clearly configured. So now what we can do is we can test Atlantis. So it's already given in this README file. So once everything is done, so it's time to um, basically test your integration. So what I'll do is I'll go back to my repository. So you can see this repository already has some Terraform code. Okay. So like you have main.tf, which we already discussed. Um, so you have couple of resources like random UID. Okay, so this is going to create some random UIDs and the count value is coming from variables. So by default, the count value for the number of UIDs and instance count are set to only one. And here I'm just creating an AWS EC2 instance. Okay. So let me also log into my AWS. Okay. So I logged into my AWS account as well. So now what we will do is, so we'll edit this variables.tf file. Okay. So I already opened it in the other window. So what I'll do is, I'll make a small change. So the number of UIDs, I'll make it to 2, and the instance count, I'll make it to 2, and then commit the changes. But this time, I'll commit to a new branch. The name of the branch, I'll just say that feature by test Atlantis, something like this, and then propose changes. So this is just like you're creating a PR, right? Okay. So otherwise you can go to pull request and create a PR from there, or else here I'm trying to create a PR and click on create pull request. Okay. So here my GitHub has some checks. Okay, checks from Git Guardian, but you may not see this. This is not required. So you may not see anything here. Okay. But here, so this is a PR event. Okay. So during PR events and issue comments events and all, your your basically your Atlantis gets a trigger. Okay. But how do you run either a Terraform plan or Terraform apply for the proposed changes? Okay. So what you can do is you can just inside the PR window, you can simply say Atlantis, I think Atlantis hyphen H, that's for help, and click on add a comment. Okay. So once you add that, okay, so immediately you will see a result. So who is sending this result is your Atlantis is commenting back on the same PR. So for your Atlantis hyphen H, it has just given all the possible commands that you can use with Atlantis. For example, Atlantis help, Atlantis plan, Atlantis apply. Okay. So these are the various commands. Of course, you can also fine tune Atlantis with custom commands and workflows, right? So what I'm going to do is I'm going to simply say Atlantis plan, so which is similar to Terraform plan. So I'm just commenting on the PR. I'm not going to even seeing the dashboard of Atlantis. Okay. So you can see Atlantis plan. Okay. You can see Atlantis is running the plan. Okay, it is running the plan here. So if you open the Atlantis UI, okay, you can see the repository and the current step, that is plan. And in fact, I can also click on this plan. Okay, a new window opens. You can see this is the plan output, the same way that you see in your local machines, right? Okay, in fact, once the plan is ready, you can also see in the same PR window. So this is the plan, um, Atlantis plan. Okay. So it says we you need to we I mean Atlantis or the Terraform is going to create two EC2 instances and two random UIDs, and also it is going to give us these outputs, right? Instance IP addresses and all. Okay. Now what I'll do is I'll simply say Atlantis apply. I'll just go and just say Atlantis apply in the same PR. Okay. So now you can see Atlantis is starting to apply your changes. Okay, you can go to the Atlantis UI, refresh this page. You will see that there is an apply step that is currently ongoing. You can see here that this is a console out, and Atlantis is trying to create. And how Atlantis is able to create AWS resources is, if you have provided access key and secret access key, you can see it has already created the instances and some random UIDs. The same will be again updated in the same PR. You can also check this PR, and these are the outputs. Okay, so this is Atlantis, sorry, your Terraform outputs, instance ID, and the random UID. So instance IDs, there are a couple of instances, right? You can also go to your EC2 console and see whether these instances are actually created. You can see I have four, but two belong to my EC2, sorry, my EKS cluster. And you can see there are two of them. Those are in the initialization state. So these are the resources that are created by your Atlantis by utilizing Terraform, right? So this is how Atlantis works. So Atlantis can be configured with various things, right? For example, if you look at the deployment file here, so we have provided Atlantis with various configurations, like what will be the URL of Atlantis, allow repo list. Okay. And the other things as well, like disable, I think we also have it. Disable auto plan. So what is the meaning of this is, as soon as you create a PR, Atlantis will automatically run Terraform plan. Okay. So initially, so that's the default behavior. But if you want to disable it, you can disable it by environment variable. Okay. So if you look at configuring Atlantis, so you have something known as server-side configuration. Okay. So server-side configuration can be provided as environment variables. Okay. By appending Atlantis followed by the variable. Okay. For example, if you want to auto merge once Atlantis apply is done, so you can also use this auto merge and then set it to either true or false. Okay. So automatically merge pull request after plans have been successfully. Okay. So this is for basically once your plan is successful, which means if Atlantis plan, so whatever command that you give is successful, then Atlantis will automatically merge the pull request. Okay. How do I just enable this is, you again go to your deployment here and add a new environment variable. Okay. So with Helm charts also, I think it works in the similar way. So Atlantis auto merge, that's the name. The value will be, you can just provide it as true like this. Okay. Similarly, there are other, Atlantis configurations. For example, um, there are many related to PRs as well. Atlantis URL. Okay. So this is what we have provided. Okay. So otherwise, if you don't update that environment variable with the proper URL, what will happen is, so in the UI, you see this plan and apply, right? So they will not have proper URL. So which means if you don't update the Atlantis URL environment variable, so these may not uh, properly get updated with the actual URL of Atlantis. Maybe they will give you the internal service IP or the service name. Okay, so they don't work as expected. So that's why you need to update it. And auto merge is one configuration. Similarly, there are other configuration like disable auto plan, okay, which we already did. So disable apply all, this is one thing. Okay, so you can fine tune Atlantis. Okay, so with these flags, and also there are certain workflow hooks. Okay, for example, if you want to do something else before Terraform apply. Okay, so you have pre hooks, post hooks. Okay, like you can run some shell scripts before running any apply command. So let's say I want to see if there are certain tags are defined or certain conditions are met or not before applying, then I can invoke a shell script. Okay, so before triggering Atlantis plan. So all such custom workflows can be built. Okay, you can also write your own Atlantis based commands. Okay, so I think it is also somewhere here. Okay. If I find suitable examples, I'm going to do another video. But for now, this is how Atlantis works. So you need to deploy it and configure your GitHub webhooks. Thank you, and I'll see you in the next one.